Oh, it's like the rock star.
All right. Okay.
Okay. All right. Hello, everybody. So my talk tonight is called Functional Reactive Programming. 3 sort of appropriate words put together. I think that I'm trying to characterize my talk with that witty subtitle because my talk is it's mostly positive, but it's also a little skeptical about some aspects of functional reactive programming, especially about whether or not it's actually a thing. So I guess you could say I'm like functional reactive programming agnostic in several ways. So who am I? I'm Erik, that's my name. I've been at the New York Times for 3 years. I primarily work on fashion projects. I spent 100 hours here in the last week working on Fashion Week, which has been fun. Not programming at all, so that's cool. I also work with the Photodesk a lot. I work on some photo editing tools as well as distributed photo transmission systems, which is pretty cool. And I also work with sports a lot on things like Super Bowl and Olympics, which is like kind of this monster that just eats all of our developers once every 2 years, more so in the summer. So I work on the interactive news desk, which means I work in the newsroom. I do reporting. I'm like 10% editor, 90% a programmer, and it's pretty fun. And then I like stuff. Okay. So, so first, before we talk about what functional reactive programming is, I'm sure, well, first let me see a show of hands. Who here has seen the concept of functional reactive programming or thinks they might have? Okay, good. A lot of people have at least interfaced with it in some way. I think I might have seen it before or used it. It's unclear, and I think as this goes along, we'll see why I am not quite sure if I know what it is. So first of all, what is it? Well, I don't think it's particularly intuitive for somebody that is coming from a callbacks-based way of handling user events or any events really. It's intuitive to a human being who maybe has never seen a computer before and thinks that this is how programming should work, and that's nice. But I think that after a while, once you become so bathed in the callback waters, it's hard to walk back. It's hard to forget what you know. It's not really a solution for problems you can't already solve. And that's something I always like to say before I introduce any kind of programming paradigm. It's not going to light your world on fire in the sense of you're like, I could never do this before, and now suddenly I have this amazing ability to create these interactives I never could. In the same way, like the first time I saw like processing, right? I was like, oh my god, I can do these things that I never dreamed of, or D3 now, for all you cool kids who do D3. It's also not well supported by most languages. It kind of demands this compositional style that isn't necessarily always at home in some languages. In JavaScript, which is actually where we'll see some examples from, well, we won't see examples, but I'll talk about some functional reactive programming libraries in JavaScript. You can see that it's kind of straining against what the language supports, but in a language like Haskell, everything's wonderful because, obviously. It's also not React.js, which I get a lot of times. So React may have some concepts from functional reactive programming. It may be built on a functional reactive style, but it's not actually a tool for building functionally reactive apps itself. So in case someone's wondering, okay, so what is it? Well, we have 2 really useful quotes here about what it is. Functional reactive programming integrates time flow and compositional events into functional programming. Okay, makes sense now, right? You guys all know what it is, so I can just go, right? That's what the Haskell wiki of functional reactive programming says. And the Elm is a Haskell-like language that compiles to JavaScript. It's what I will be talking about tonight. It describes it as control flow structures for events. So is everything. So neither of these are particularly lucid about what functional reactive programming is. So rather than tell you what it is, I'll give you some pillars of what I see in functional reactive code. And I should warn you that even the godfather of functional reactive programming, Connell Elliott, actually would probably disagree with me on what functional reactive programming is. But I'm just kind of like, I'm really like ecumenical when it comes to programming terms. We were talking about this last night. Like, I think that if you are some people will say you must be specific because without specificity we are lost and we are just savages. But I say sometimes you can be too specific and you can drive out any kind of like collaboration in a certain space. So we'll see. I'll try to walk that tightrope. All right. So what's the probably the biggest idea in functional reactive programming. And I would say if there's nothing else you take away from this talk on functional reactive programming is that functional reactive programming introduces this idea of a time-varying value, right? In some systems it's called a signal, and that's the one that I will be using because I think signal, it captures what it is probably the best, because when I think of a signal, I think of an audio signal, right? I think of like a waveform or something like that, a music signal. And I think that that is kind of the archetypical rather, time-varying value. Like, it's not just its value at any time, right? Like, that would be kind of silly to think of that way. It's like this holistic thing that changes as it goes along. Other places, I think originally it was called a behavior. It was this idea of a time-varying value. That is what it was originally called. But I don't really think that's necessarily the best word for it, because I mean, there's tons of things when I think about behaviors. Sometimes people just use behaviors to mean like what something does. And other people call it streams, and that's cool too. I think streams similar to signals. Also, other ones called events or event streams, which is actually like kind of a perversion of how event was originally used in the functional reactive programming literature. So I'm just not even going to talk about that. I'm just going to go with signals. Is everyone cool? If I say signals, no one's going to be too upset about that. That's what Elm calls them. So. Cool, right? So again, when I say time-varying values, I mean that past, present, and future kind of coalesce in a certain value. And we'll see what I mean by that in a second, but rather than saying, on click, do this, we say, do something for all clicks, or something like that. And you'll see what the difference is. I will show you an example of the code right now. So in JavaScript, right, I'm sure anyone that's written JavaScript has written this basic thing before. On click, here's our callback, log the position of the click. Does that seem sane to everyone? Like, let's start on the same page here. Are we all cool with that? It seems like a pretty straightforward example, right? In functional reactive programming, rather than you'll say on clicks do this thing, you'll say lift, and lift means basically like promote a function that operates on a value to operate on a signal instead, right? Some functional reactive programming systems use map or something like that as a similar kind of a similar word, basically kind of getting you into the mind of, it is a mapping operation, right? It's a function that operates on an internal value kind of being applied to something that's wrapped up in stuff. That's not purely what a map is, but let's go for it now. So basically I'm saying operate on this signal, the click signal, all the clicks, right? I want to log the position of all the clicks, which accomplishes the same thing as that, but I'm treating clicks as a thing. All the past, present, and future clicks as a thing. So whenever I get a click, its position will get logged out. Does everyone feel pretty comfortable reading this now? Cool. Okay, good. Excellent. So I like to say, functional reactive programming reifies a whole bunch of events as a thing. I like to think of it that way. I mean, and I'm using reify in the philosophical sense, not the programmatic sense, because I'm a philosopher, not a programmer. Okay, so the second big idea in functional reactive programming is composition, right? Now, this isn't necessarily a discrete idea. It might be more of a side effect of functional programming or something like that. But what you end up seeing as a big advantage of functional reactive programming is all of your functions that operate on your signals, and then the signals themselves can be composed together to create new signals and new operations over those signals. And I use this kind of illustration, so for people who are wondering, this is y equals 0.5x, and this is a sine wave, and then if you do y equals 0.5x plus sine x, then you get this kind of thing, right? But this is also exactly what like audio processing often is illustrated like. Now, I don't really know what this corresponds to audio processing, but sometimes if you look at like what like a guitar pedal does, or like a whole board of guitar pedals chained together, you'll see diagrams similar to this to see like what it means to compose two signals. Well, just like you can compose two signals from a synthesizer or something like that, you can compose signals in functional reactive programming. Now, what does that look like, and why is that cool? Well, if we replace callbacks with functions and signals, then we can compose them and combine signals. That's just what I just said. But I just want to go over that one more time, is that one of the advantages of, instead of saying on click do this, and instead of saying do something over all the clicks, is because then I can mutate clicks. I can change it and make it more complicated, and we'll see some really cool, well, I think it's really cool, things like this. Also, functional programmers love composition, so if any paradigm can shift something towards composition, not only does it allow them to do what they like to do, it also makes them deeply happy. Because there's something that happens with functional programmers where the purity of their system, especially if it's something like Haskell, will say like, you can't do all that stuff easily that you can do in JavaScript, like one click do something like that, right? You just can't, we won't let you do that, right? So then we have to evolve something else, like monads, right? You can't have I/O, so we evolve monads. So then of course we have to then say monads in themselves are a good. So similarly, composition is a good in and of itself to a functional programmer. Now just to give you a couple of quick examples of what I mean when I say composition is king to an FRP, in JavaScript I might say on click, increase a counter, and then on button press, increase a counter. Cool, makes sense, right? I mean, I don't really know why you'd want to do this, but you know, whatever, it's cool. So in FRP, what you can do is you can say, okay, take the increase counter function, right? And then lift it over this big signal. Like, just think of this as one big signal right now, right? Well, how do I make that signal? Well, I just combine all the clicks and all the presses and make a new signal. I just merge them together. Now, what merge means in Elm is just take the two streams and basically combine them. So if you get two things at the same time, it'll bias the first one in this, but it'll just take all the events and put them through into one big signal. The simplest way to compose signals. And then similarly, you can also compose the functions you lift over them just with normal composition. If you haven't used functional programming before, like Haskell or something like this might seem strange, but this function is just the result of combining the increase function with the log function. So over here it says, okay, increase the counter and then log, the value. And this says increase the value and then log the result of the increase function. It's just like the open circle in like math. Math. Some math, I guess. So what if you wanted to say respond to simultaneous clicks and presses, or I only want to respond to a click that comes 1 second after a key press? You might say like, oh, that's kind of crazy. Why would I want to do something that ridiculous? But I tell you, this happens all the time in complicated UIs. I was building this photo editing UI, and they wanted to be able to tab through slides, but they wanted to be able to stay in the same text box when they tab through the slides. But they wanted to also have like another feature that allowed them to like tab between, the actual text boxes on a slide. So I had to basically say I had to implement like Street Fighter style buffers, right? Where it was like if you click it within 1 second, then it will do this tab to the next slide, but otherwise it'll operate as a normal tab. This kind of stuff actually really does happen in complicated UIs. So you'll see that in a little later. This is just a little teaser to whet your appetite, and I'm sure you can. I can't wait for that. It's going to be the best. Okay, cool. The other third idea is everything's a signal. Eventually, in my code examples, I'll start marking in blue the things that are signals, and very quickly, the whole thing will be blue. I'll signal everything. Is a good way to think of functional reactive programming, because you take after you lift a function over a signal, the result is another signal. So you just keep making bigger and bigger and bigger signals, and then finally your actual big program is just a really big signal, at least in Elm, and that's good. But there's a reason for that. And this is something that's actually not as clear to me when I started as it should be, which is that you have to think in terms of signals. So you don't say, oh, I want to conditionally fire this if something else is happening. Instead, you want to say, I want to mask this signal with the other signal of the thing I want to conditionally fire on, right? So I don't say map this function over all my clicks, then check it, and that function will check if something is down. No. I'll say I have my click signal, then I have my presses signal, and I'll combine them in a certain way that masks the one with the other. And we'll see that in a second. But what's the virtue of everything being a signal? Well, then state becomes basically just a signal. It becomes a value that you're just passing, just constantly passing through your signals in the same way that you pass accumulator value through a fold or a reduce, right? State just becomes threaded through your signals. Granted, you also can't have global state in Haskell or Elm. That's just not possible. Well, you can't, kind of. But in the same way, you can't just have something that says state.foo right to that. You can't do that. So you have to just always be kind of threading this value through. And as a result, you get this purity. Now, why is purity good? Well, I'll show you in a second what happens when you don't have purity. Refactoring becomes harder. Debugging becomes harder. Cool. So everything's a signal. Illustration of that. Before, say I wanted to maintain a global count of all my clicks. Reasonable, right? In JavaScript, I might do on every click increment state.count. Reasonable, right? But What happens if someone else changes state.count? What if you forgot somewhere else in the code you said, oh, when like the moon aligns with Mars, state.count should equal -2. Like you might forget that. You set it to do that. Or it might be doing something more insidious where state.count gets mutated without explicitly referencing state.count. Right? It might say state.count, like loop over it and clear everything out or something. I don't know why. We do crazy things like that sometimes. But in FRP, you don't open yourself up to that domain of errors because the only state you have is this value that's being folded through your signal. Now, what do I mean by that? Who here is familiar with the idea of a fold or a reduce? Okay, so some people are, but not everyone, so I'll go through it again. Not again, for the first time even. A fold or a reduce basically says, take an array or take a list or something or a signal, which is like an array-like value in a sense, and apply a function to every value of that, and then also kind of like an accumulator value. So a great example is this one. This is the simplest fold, right? This is take a plus. This is the initial value. Start at 0, right? And then for every value on my click signal, right, add it to my current value. And the result of this is like a summation of all your values, right? So if I wanted to sum an array of integers, I would say fold plus starting with 0 over my array. Does that make sense to people that haven't seen fold or reduce before? That's like the kind of 50-foot view. But you basically say the same thing with functional reactive programming. And the nice thing about that is it means nothing else can touch this value. I mean, sure, like if we want to get really pathological, something could get into my memory and mutate that value. And that probably is something that actually happens on computers sometimes. But at least from a code perspective, at least from an optimistic perspective, nothing outside of this function can change this value at all, other than what values we get through clicks. So that's a cool thing. That's a nice thing. Because I don't have to ever ask, well, why is it that value now? The answer has to always be, well, clicks gave me a weird value, or I don't understand how plus works. In which case, there might be other problems. So what are the advantages of FRP? Well, so basically, signals are composable, traditional events are not. You have a whole bunch of clicks, you have no way of combining them into a more complex event, which means it's harder to reuse complex events. It means it's harder for other people to write libraries that involve complex events, such as for 1 second after I make a button press, et cetera, so no one ever does it. And it's harder to model these as complex events. It's easier to trace a chain of custody when you have this kind of like purity that I was showing you before, because I can point to, it can only come from these areas. It can't come from another module I imported. It can't come from another place in the code. It can only come in like one of these 2 areas. By the way, I'll show examples for all these in a second. And also, declarative code is easier to read. Now, I don't necessarily believe this, but a lot of people seem to, so we'll let the jury stand out on this. The argument is that declarative code is more like how you think. It's more like how one speaks, right? It says what you want to do rather than how to do it. This might be true. I'll let you decide in a second. So for complex events, let's model an app that tracks mouse position, but only for 1 second after every mouse press. So maybe this is an art app where I can press a button and it's like a spray can or something like that. I don't know. Maybe it's like I can focus on a text area, and if I move out of the app, it'll like unfocus, but only for a second after I've clicked. I'm sure there's a reason you might want to do that. I don't know why. So in JavaScript, you might do something like this. And I apologize for people that write JavaScript and people that don't write JavaScript that you have to see this. So what you might do is you might say, on click, set up an interval. Which an interval means something that happens every n milliseconds. So on click, every 50 milliseconds, call this update mouse position function. And we'll say update mouse position finds what your mouse position is and like renders it or something like that. Cool? So you'll do that. But then you'll also say set timeout, which says do something n milliseconds away from now. Set a timeout for 1 second, which says after 1 second, clear this interval, which means stop updating mouse position. Does this all seem like a reasonable way to do what I just described? Update your mouse position for 1 second after every click. Okay. Now, there's a couple problems with this. I mean, it doesn't look great. There's a lot of functions being passed around in such ways that I don't necessarily know how to change them if I wanted to like refactor my code, like say extend it to conditionally fire if also pressing a spacebar or something like that. it's not exactly clear how I would say, okay, well set this interval if something else is going on. It gets pretty messy. Because like, say I say, oh, only do this if the spacebar is pressed down, then I have to say like, well, should I still clear it? Or what if I do it twice in a row? It just becomes kind of messy. So in functional reactive programming, we have something a little different. Instead, we say, okay, keep when, and this means for 1 second, so since a second after every mouse is down. So for 1 second after every mouse is down, keep the mouse position. This is just like an initial value because everything in functional programming needs like an initial value. But just don't even worry about that. So basically it says, for 1 second, for every mouse press, keep the mouse position. And that makes a signal, which means that the signal will change for exactly 1 second after I press the mouse button, every time I press it. And then this is just saying, display that as text on the screen. I don't even really need this, I just want to show that. Let's count the signals. This is a signal, 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 and that's a signal. So my comment about everything being a signal, I think, is borne out by this example. And so now the nice thing is that this tracks item that I made is ready to compose again. So now I could say super tracks or something like that equals keep when second since spacebar is down or something like that if I wanted to only do it when I have the mouse down and a spacebar. So you can see it builds on itself very, very nicely, I think. In a much easier way than this builds on itself, which I have to introduce new control structures, I have to introduce new kind of conditionals and all kinds of extra cruft if I want to just make it a little more complicated, rather than just kind of stringing things together. Second of all, it's easier to trace a chain of custody, and what I mean is, how many times have you made a program a JavaScript program where the end of it looks like something like this, right? Where it's like, on the click this, do that, on click do that, on mouse press do that, on mouse move do that. And you have like all of these in a row, and at some point someone goes, what updated state.foo? And you're like, one of these things did. Control F, state.foo. And then you're like, oh, nothing's showing. Oh, no, I just refer to it as this.foo. Okay, this.foo. Okay, no, that's not right either. You know what I mean? Like, we have a hard time figuring out what updated it, because anything can write to it. And this is, again, a purity concern. So functional reactive programming encourages what I've termed a linearization of responsibility, with no reference to any literature or any of these words. Like, I just made that term up. But it sounds official, so please tweet that out and put my name on it. So basically, in functional reactive programming, if what we want it to do is say, I want to create like a little control scheme for like a platformer that responds to arrow keys, or a spacebar as an up arrow. So what I would do is keyboard.arrows, and whenever I press a button, it basically emits another value in the signal that is like left and right. So if I press the left button, it's 1, 0. If I press the up button, it's 0, 1. You get the idea. And then this just says, make the spacebar act as one of those. So this says, on keyboard.space, emit a 0, 1. Okay, that makes sense. And then I just merge them together. So now I have like arrow keys and a spacebar that all work in concert. And then I say, okay, well, whenever any one of those updates, I want you to update the signal that is a pair of any key event and whether or not the mouse is down. So whenever the mouse state changes or a key state changes, it'll emit another event on this signal. And then finally, I just say process all that stuff. So it becomes pretty easy for me to trace what affected where I say, okay, maybe my problem is like, why did I get a 0, 1? Okay, so I can just kind of trace it back. Well, I got the 0, 1 in the second value, so it definitely has nothing to do with the first value. It doesn't have anything to do with mouse is down, so it must have something to do with this. So then I say, well, which is the one that was wrong? You know, okay, I didn't even press the spacebar. You get the idea, right? You can kind of walk back up, and it's impossible that anything else got in the way, which is cool. And by impossible, I mean like impossible. And then about the declarative being better than imperative, this all might be BS, I don't know, but the claim is that declarative code trumps imperative code because it just does what it says it does. Sure it does, but you know, eventually you're going to get boilerplate in there, and it's going to be like a less than our like kind of canned example. So to go back to my previous slide, I can just read this. Anyone can just jump in this code and knows exactly what it does. Keep for 1 second the mouse position after I press the mouse down. I can just read it. It's just like English. Well, there's actually no proof that like things that are more like English are easier to read or easier to remember. In fact, there's some research I've read that actually suggests the opposite's true. So I don't know. Might be, right? Who knows? Not me. Okay, so let's go through a quick sample. I have some time. So, okay, so let me show you what we're going to make really quick. So we're gonna make this thing. Okay, so we're at the New York Times, right? So we're gonna make this little jumping game. It's like a little platformer with the New York Times masthead. Become a New York Times chauvinist. Okay, so there we go. So let's see what it would look like to make that. Okay. So this is the code. I put all this stuff down here that, I mean, it's going to get a little simpler in a second, but I put all this stuff down here they don't really need to worry about. This is like the physics, the jump physics, the walk physics. Basically, like, this would be pretty similar no matter what language you wrote it in. It's just like calculating, like, if I press jump, like, how do I keep updating Mario's position, right? Or not Mario, the New York Times masthead. By the way, this example is on the Elm website, and I intentionally chose one. Maybe because I'm lazy, but also because then you can go back and look at it and like further enrich yourself. So let's go with that explanation. So first, let's read the program backwards. So first it says lift2, which means just apply this function of 2 arguments to these two signals. Window.dimensions is like the signal for like basically resizing, but it's basically a signal that will always have emitted what the last window size is. Its value will always be what the last window size is. And then this is a signal that basically its value is whatever our last input is. So basically it's saying render like the game, right, based on window dimensions, and then like the updated value based on our input of the masthead or where Mario is, depending on what you want to say. Cool. So then, what does our input signal look like? Makes sense. Okay. So basically, what it says is we have this delta value, which basically just says did the frame update in time. So as you know, computers aren't perfect. Might be a shock to some people. Like, computers aren't perfect, and sometimes even if you say I want it to update 25 times a second, sometimes like maybe your processor is like not to launch. Maybe it's like downloading some videos or something like that, and maybe you only update it 24 times a second. Well, so this just helps to control for that, to smooth it out. This just says every time the signal updates, see whether or not it truly is on the clock correctly, and if not, what should be my value by which I adjust it. So the delta is just like saying your time adjustment. Don't even really worry about that. So then this just says, okay, so on this delta, which should update every 25 seconds with information of how off it was, on that time update, update the signal of the keyboard arrows. So that basically means filter out all the keyboard arrow events so that it only updates on our clock. And that's, again, to smooth out the input of the game. Because if you don't know, that platformers and games work like that. That's how you get a consistent input, and you don't get like your character, like if I hit 2 times fast, like he moves in a strange way and things like that. So this is what I was saying about complex events becoming easier to manage, because here I'm taking an event I understand, like the signal of keyboard arrows, and I'm smoothing it out. Right? And I'm smoothing it out in such a way that I don't have to introduce new logic inside that event. I just say, okay, we'll only sample it once every 25 times a second. So once every 1 second divided by 25. And then finally, based on the information I get from that sample, update the character's position. And it's saying that the character's position updates by, like, first register the jump physics, then the gravity physics, and the walk physics, and then the physics. And I'm using physics as kind of like a hand-wavy term that means like all the things that help calculate where your character is now based on where he was and what you wanted him to do. So again, we have composition right here. It's really easy to understand, like, first I check his jump, then his gravity, then his walk, then his physics. That's how he updates. It becomes very linear, very easy for me to read and check bugs out. I can then, if I wanted to, I could compose this further. Maybe I want to mask it out so that maybe he's in like a world where once every minute it goes black and it's like, what a horrible night to have a curse. And and then during that time, his jumping becomes like twice as strong or something like that. I could then mask this out by like once every minute to I could mask that by like sample on FPS, like whatever once every minute is in seconds. So that's kind of cool. Let me just go back to that real quick. Does that make more or less, I mean, like, obviously you're not going to be like, oh, obviously this is all intuitively obvious. I've never even seen this kind of code before, this language, but totally I get it. I just hope that you can like maybe then go back to the example and like play with it and be like, oh, that thing he said makes sense now. I understand why he has sample on delta. It's so that this doesn't update too many times to like throw off the animation. Because if you tell your animation to update more than it can draw, it's going to like cause a bottleneck. So there's different things like that. There's a lot here, but I think it makes sense. Okay, so one other thing I want to talk about right before I leave is there's this thing I like to call the David Nolan test. So David Nolan was once a coworker of mine, and he's a closure head, and he writes a lot about concurrency and things like that. And when he was introducing a new concurrency model in Clojure called core async, Clojure script he does a lot of as well. He kind of put this test to people, which was, kind of, not explicitly, but I took it as a test, I took it as a challenge, which was like, can you make a thing that basically shows 3 different signals updating like a list of process 1, 2, 3, and show that they're interleaved, right? So, and I just wanted to show, and he even mentions like, FPS fans might recognize this, so I want to show you how you do it in FPS. It's actually really simple and really, really cool. And there's, without any obvious use of mutation, which is exciting. Okay, so let's go. So first we say, process 1 says 4 times a second, emit a process 1. Everyone on the page? Everyone on the same page? Good, good, okay, cool. Now, process 2, once a second, emit process 2. Okay, cool. So like this will be a fast responding server, and this will be a slow, because 250 milliseconds is a really fast server. And then this will be a slow server. And then this will be once every second and a half emit process 3. So if we look at this, which we almost not done, what you should see is process 1 really, really frequently, process 2 a little less frequently, and process 3 like, it's like an absentee friend. And then all you have to do is you basically say merge them all. Now you say, but what's all this stuff? Well, that's just me making sure that the array only stays at 10 items, so that it doesn't like scroll infinitely. But it's just some code. It's not even like good code. Don't worry about it. But so basically, I just say merge them all, and that's cool. And then this is just how I actually display them. There's lots of cool things about Elm, but one of those cool things is that rendering things, whether it's HTML or Canvas or anything, all works through the same paradigm as just like put elements on the page, and that's one of its kind of foundational ideas. So let's look at that. Let's see, does it pass? Oh, look at that, it does. So cool, you can see that 1 appears really frequently, 2 a little more frequently, and then 3 less frequently. And that's all the code you need for this like kind of concurrency. Now, remember I said one of the things we were shooting for is without any obvious use of mutation. All we have is this accumulator value, which is being passed through over and over again, and it's not being mutated because it's being like copied, right? So there's no obvious use of mutation. Otherwise, in JavaScript, I'd have to say something like set interval 250 milliseconds, push process 1 into a thing, and set interval, every 1 second push into a thing. You get where I'm going with this, right? But the problem is I'm mutating something. I have to have this other state out just hanging out there. But what happens if something else causes that state to get out of whack? Say I'm just pushing like LIs onto an OL, well, what if something else starts pushing LIs? What if I have another render event? What if I accidentally blow away my thing? What if Chrome decides that I can only have 4 LIs in every OL because it's a new micro optimization that's written? I don't know. There's no way for me to like really, really understand that. So this basically says no state. You don't have to worry about that. And as long as each one of these works on its own, there's no danger in anything coming out, and messing up that state. As long as my fold function is sane, no one can introduce any code outside of it that can break it. I mean, again, sure, okay, but that's at least the virtue of the purity. So I'm sure right now you're saying like, okay, this is great. I want to, as soon as I've done like hearing these other cool speakers, I want to go and try it right now. How can I do it? Okay, good news for you, you can. So all of these examples have come from elmlang.org. This is, like I said, a Haskell-ish functional reactive programming language framework that compiles to JavaScript. So that's cool. So you can all just go home and write this code, compile to JavaScript, and replace all of the code that you're running on your production work site with Elm. But if you don't want to take the full plunge and compile to JavaScript, because compiling is like awful, then you can use RxJS, which I think is related to Java, or I don't know anything about Java. But it's reactive extensions, and that and Bacon.js are like functional reactive programming, kind of. I'm not trying to like diminish them. It's just like JavaScript doesn't let you do like all that cool composition and stuff that we did quite as nicely. So they have to compromise a little bit. It doesn't enforce purity, which makes it like, you know, like that's kind of a bummer. Like purity is the whole reason. Like so many of these things were really cool. But again, like, you know, like devil on my shoulder, Erik is like, well, purity is also like enforced by the language. So this is actually just a way to get around the fact that we can't have the state that we want in the first place. Monads. So yeah, these are both kind of good and very useful. So then there's, if you use Haskell, then I'm sure you've probably written your own functional reactive programming language already, library already, because there's like 800 of them. But the ones that I see like get updated a lot, and well, is Reactive banana. I don't really know what the banana part is, but there's like other like fruits. I'm sure there's like an inside joke over drinks that I don't understand, but that one's cool. And then there's also NetWire, which I really like. It's another functional reactive programming language that has proper arrows. And you know, finally, I was wondering like, when would someone force me to use arrows? Well, NetWire will not only force you to use arrows, but like make you question whether or not you know anything about programming. So those are all the functional reactive programming libraries. I would advise starting with Elm if this is your first go around, because it seems very simple and very distilled. I'm sure other people would say it's not even real functional reactive programming, because that's how the internet is. But yeah, so that's those are all the things you can play with. And yeah, cool. Let's ask some questions.
Enjoyed that as much as Daniel and I did. So, all right, so any questions for Erik? Oh, yes, Dan.
Not so much a question, but a quick clarification. The banana comes from OCaml. The operator for applicative composition in OCaml is paren pipe, as they call the banana brackets.
It's just as not funny as I thought it would be.
Exactly.
Thank you.
Anyone else? Comments, questions?